Can you imagine witnessing a cosmic explosion so powerful that it casts shadows on Earth, even in broad daylight? That could soon become reality. Betelgeuse, a massive star in the Orion constellation, is behaving strangely, a sign that it may soon erupt in a spectacular supernova, lighting up our sky in ways unseen before. But when will it happen? What will it look like? And what secrets could this reveal? Let's dive deep into Betelgeuse's mysteries and explore the possible impact of its explosion on Earth and our solar system. Betelgeuse, a giant on the verge, situated roughly 650 light-years. From Earth, Betelgeuse is no ordinary star. It's a red supergiant, shining with a luminosity over 100,000 times greater than our Sun. But Betelgeuse's significance isn't just scientific, it's cultural. Named after the Arabic Yad al-Jawza, meaning the Hand of Orion, it has guided travelers and enchanted stargazers for centuries with its distinct reddish glow. To grasp its immensity, if placed at the center of our solar system, Betelgeuse would engulf the orbits of Mercury, Venus, Earth, and possibly even Mars. Despite its staggering size, Betelgeuse is relatively young, only about 10 million years old, a fleeting existence compared to our 4.6 billion-year-old Sun. The anatomy of a supernova, massive stars like Betelgeuse live fast and die young. They burn through their nuclear fuel at a rapid pace, leading to a much shorter lifespan. As Betelgeuse nears the end of its life, it's set to culminate in a dramatic finale, a supernova, one of the most powerful explosions in the universe. The last supernova visible from Earth occurred in 1604, famously observed by Johannes Kepler. Should Betelgeuse explode, it could outshine even the full moon for weeks, offering humanity an unprecedented spectacle. Betelgeuse's recent odd behavior. Since late 2019, Betelgeuse has exhibited puzzling fluctuations in brightness. Its great dimming sparked intense speculation among astronomers. Although it appeared to recover by mid-2023, a surprising 50% surge in brightness followed, raising questions about its stability. Could we be on the cusp of witnessing Betelgeuse's final moments? Astronomers are closely monitoring every change, hoping to unravel the star's secrets. The Great Dimming. What happened? Why did Betelgeuse dim so dramatically? Stars, much like Earth's seasons, often have predictable cycles of activity. Betelgeuse typically follows a 400-day brightness rhythm, but the Great Dimming defied expectations. A leading theory suggests that Betelgeuse underwent a massive surface eruption, ejecting a colossal amount of material into space. Observations from the Hubble Space Telescope revealed that the star expelled surface matter equivalent to several times the mass of our moon, forming a dense dust cloud that temporarily veiled its light. As the dust dispersed, the star's brightness returned to normal, but the event hinted at deeper instabilities within. Will Earth be affected by Betelgeuse's explosion? Understandably, many wonder, if Betelgeuse goes supernova, will it endanger Earth? Fortunately, despite its impressive power, Betelgeuse is far enough away that the explosion would pose no direct threat. Instead, it would offer a rare celestial show, lighting up our sky for months, perhaps even visible during daylight. However, the radiation and cosmic rays released would enrich the interstellar medium, contributing to the ongoing cycle of star formation throughout the galaxy. Inside a dying star, massive stars evolve through complex stages of nuclear burning. Initially, stars fuse hydrogen into helium in their cores, the main sequence phase. As hydrogen runs out, they switch to burning helium into heavier elements like carbon and oxygen, expanding into red giants. Betelgeuse is currently in a late stage of evolution. Some researchers, like those at Japan's Tohoku University, believe it is in the carbon-burning phase, suggesting the core collapse and resulting supernova could occur within a few decades. Others, Part of this sentence is missing in the original text, so I cannot complete it accurately without making assumptions. I'll leave it as is to avoid introducing errors. Argue it may still be burning helium, implying we might have tens of thousands of years to wait. Regardless of the exact timing, Betelgeuse's fate is sealed. It will become the Milky Way's next supernova. The time machine effect. A fascinating aspect of astronomy is that when we observe celestial objects, we're looking into the past. Light from Betelgeuse takes about 650 years to reach Earth, meaning the light we see today actually departed when the Renaissance was just dawning. If Betelgeuse had already exploded, we wouldn't know yet. Its light is still racing toward us across the vast cosmic ocean. Every glance at the Orion constellation is like peering into a time capsule, catching glimpses of a long-lost past. A glimpse into the future. Earlier this year, astronomers observed a supernova designated SN 2023X in a neighboring galaxy. This event provided a tantalizing preview of what Betelgeuse's end might look like. A breathtaking, luminous eruption briefly outshining its entire host galaxy. SN 2023X's characteristics, its brightness, spectrum, and aftermath, have helped scientists model expectations for Betelgeuse's grand finale. It reminded us of the unpredictable and awe-inspiring dynamics at play in the universe. Conclusion. A moment to remember. Whether Betelgeuse explodes tomorrow or 100,000 years from now, it serves as a vivid reminder of the incredible forces shaping our universe. Its eventual supernova will not just be an astronomical event, it will be a moment that connects humanity across cultures and generations in collective wonder under a changed night sky. Whether it's the enigmatic Betelgeuse or a distant supernova like SN 2023X, these cosmic events highlight the dynamic, ever-changing nature of the universe. Space exploration remains filled with uncharted territories and unresolved mysteries, particularly when it comes to understanding red supergiants like Betelgeuse. These colossal luminous stars, while dazzling to observe, still guard some of the universe's deepest secrets. Although scientists have outlined the general life cycle of red supergiants, from their main sequence origins to their massive supergiant phase, many transitional stages remain poorly understood. During these phases, violent internal disruptions and changes in surrounding material occur over millions of years, and evidence suggests significant transformations take place, sparking ongoing research and debate. One particularly puzzling aspect is the immense mass loss these stars experience toward the end of their lives. The causes, rates, and mechanisms of this material ejection remain largely unknown. Recent fluctuations observed in Betelgeuse's brightness have only deepened the mystery. What would happen if Betelgeuse exploded as a supernova? Dr. Stenny from Western University suggests that when it eventually detonates, it could become one of the brightest objects in our night sky, outshining all stars and possibly even rivaling the brightness of the moon. Despite being about 650 light-years away, its explosion could turn night into a shimmering day for weeks or even months. After this dazzling display, the light would gradually fade over months, and eventually, the star's remnants would form a planetary nebula, a glowing shell surrounding the faint core left behind. Scientists worldwide are actively studying the potential effects of such an explosion on Earth. There's speculation that the supernova could release cosmic rays, high-energy particles traveling at near-light speed, that would interact with interstellar matter. Upon reaching Earth, they might enhance auroral activity. Fortunately, Betelgeuse is distant enough that any cosmic radiation would be heavily attenuated by our atmosphere, posing no significant threat to life. Beyond the scientific impact, a supernova of this magnitude would leave a lasting impression on human culture. A sudden dramatic change in the familiar night sky could provoke deep philosophical reflections on impermanence, cosmic timescales, and humanity's place in the universe. Historically, celestial phenomena have inspired new eras in art, literature, and science, and Betelgeuse's explosion would likely be no exception. On the scientific front, such a supernova would be a cosmic laboratory. It would offer astronomers a unique opportunity to study the mechanics of stellar death, the creation of heavy elements like carbon, oxygen, and iron, and the seeding of these materials into space, critical ingredients for future star systems, and, ultimately, life itself. The blast would also generate shock waves capable of compressing interstellar gas and dust, triggering the birth of new stars. This cycle of stellar birth, death, and rebirth reflects the deep interconnectedness of cosmic structures. Moreover, Betelgeuse's collapse could provide valuable data on gravitational waves. These ripples in spacetime, first observed in 2015, offer a new way to explore the universe, and a nearby supernova would present an ideal event to refine our understanding of these phenomena. Culturally, the impact would be profound. A bright supernova visible to the naked eye would likely spark a renewed public passion for astronomy and space exploration. Educational institutions could seize the moment to inspire new generations of scientists and thinkers. Betelgeuse's recent behavior, unexpected dimming and brightening, provides rare insight into the final stages of a massive star's life. Such stars burn their nuclear fuel at a ferocious rate compared to smaller stars like our Sun, hastening their collapse and explosive end. Predicting the exact timing remains a formidable challenge. But should Betelgeuse explode, it would provide an unprecedented window into phenomena like neutrino production, offering scientists a wealth of new data about these elusive particles and their roles in stellar processes. The resulting shock waves would also enrich the interstellar medium with vital elements, setting the stage for new star and planet formation. In this grand cosmic cycle, the death of one star paves the way for countless new beginnings. Though Earth would remain physically safe, the broader impact on science, philosophy, and culture would be enormous. The spectacle would deepen our understanding of the universe and fuel new questions about existence, knowledge, and exploration. Ultimately, Betelgeuse's potential supernova is not just a matter of scientific interest. It represents a profound moment of transformation for humanity's understanding of the cosmos and our ongoing quest for meaning in an ever-expanding universe.